Let's get it going with dependency cultures. I'm Richard Feldman. So I used to live in St. Louis, Missouri, which is just like a 2-hour drive from here. It's no Columbia, but it does have a lot of cool things going for it, such as the arch here. Now, I lived there a long time ago. The arch was not quite done. There was no color photography. This was 20 years ago, and we had web startups back then, but they were, of course, very primitive by modern standards. This was our tech stack. We ran Debian Linux on physical servers that we put together with our hands and walked over to a co-location facility downtown. We used Apache HTTP server, running Perl. Anyone ever done any Perl? Cool, nice, all right, yeah. Yeah, you know what's up. So, and then we had a big dependency that we forked called MW Forum because it had authentication and stuff like that, and forking was like kind of a normal thing back then. Postgres, Memcached, we sent mail from our own servers using SendMail. And then JavaScript, which actually did have that logo back in the day. We ran jQuery. Anyone ever use jQuery? This is like ubiquitous, yeah, all right. This is a great crowd. Okay, so, and then jQuery UI for stuff like this really cool calendar picker that we had. If you go back a decade before that, like 1996, this is a famous web startup. We're going to see if anyone knows the name of it. They were running bare metal servers, of course, and FreeBSD. Then on top of that, this might give away which web startup it was. They used Common Lisp and then C for the high performance stuff. The author of this book, ANSI Common Lisp, is another clue. Anyone know what startup I'm talking about? ViaWeb, yeah. So this is basically like they called it ViaWeb because they had this novel idea of delivering software via the web. This is like arguably the first web app. As far as like CSS and JavaScript and database, none of that. So it's like CSS was like, I think came out in 96, it was like very new, JS 95. Database, apparently their investors were like, you're gonna need a database. They're like, nah, flat files are fine. But they sold this company to Yahoo for millions of dollars and then went on to fund Y Combinator using all the money they made off it. So I don't know, it's scoreboard. Now, by modern standards, this is like fully black and white era. Modern standards, slightly more dependencies. So these days, you're not going to be putting your bare metal servers together. They're going to be in a data center somewhere where they have a whole bunch of them that other people run. They're probably not going to be running like a vanilla Linux or BSC. They're going to be running like Firecracker for AWS Lambda. On top of that, you're going to want Vercel to abstract over your abstraction over your abstraction. Then you're going to have TypeScript on top of your Node.js. Then you need Next.js because if there's one thing we learned from Delaney's talk yesterday is that you should always mix client and server state. Then you're going to want Prisma for your ORM, Better Auth, because who doesn't want Better Auth? You're going to use Neon because that's an abstraction over distributed Postgres, abstraction on top of distributed Memcached, or I think it's Redis, Resend for doing mail because you don't do send mail anymore. S3 and CloudFront, that's old school. You want Vercel stuff on top of that for abstractions on top of your abstractions on top of your abstractions. Then you're going to need Tailwind, CSS, React, Next.js because you need it on the client and the server. Tan stack, so your stack is nice and tan. And base UI for accessible components, but they're not very stylish, so you're going to want shad cn/UI on top of that. So things have changed. Now, if you look at this evolution, one way you could look at this and you could say, like, this is all still just like websites. You get like HTTP traffic in, and then you like maybe talk to some other stuff, and then you send the response back. You could, if you wanted to, still use this 1996 ViaWeb stack today, and I think that's pretty much what Hacker News does. They might have like 2 servers that are bare metal. But most don't. Most do this sort of more normal thing, you know, that we see here. I've been out of the game long enough that I don't recognize half of these technologies. I had to learn about them for this talk. But a reasonable question you could ask here is like, how much of this is technical? Like, how much of this is people making really deterministic, like, careful consideration and saying, on a technical level, this is the absolute best set of dependencies for me. I've figured out we shouldn't have any more than this, we shouldn't have any fewer than this. And how much of it is cultural? How much of this is saying, I'm going to do these things because they did, or because that seems to be what you kind of do these days. Or like, I don't know, that's just like, I don't want to think too hard about this. So I want to do a quick comparison of some websites in the year 2026. These are the current websites as of this month. Each of these is a website for a programming language. They're all basically doing the same job. I want to compare some anonymous dependency graphs of different levels of dependencies that you can use to do basically the same job. So the websites are TypeScript, Node.js, Python, Ruby, Rust, Zig, Go, and Rock. All right, so here's the graphs. These are the number of direct and indirect dependencies for each of these static websites that are each about a programming language. Again, doing basically the same job. There are 8 bars on this graph, but one of them is 0 pixels, so you kind of can't see it. One of them has almost 1,800 dependencies, almost all of which are indirect. So an indirect dependency being, I depend on this thing, but then this thing brings in several other indirect dependencies. So a question here, which of these two websites, again, I haven't labeled them, so which of these two bars would you guess are the ones that compile programs on the website? So what I mean by that, and I'll tell you that the two are TypeScript and Rock without telling you which bars they are. So if you go on either the TypeScript website or the Rock website and you can type in some code in their respective programming language, you can press run and you can run it and see what the output looks like. So if you had to guess, which two bars would you guess represent the websites that actually have on their website a compiler that's not going to a server, it's being done on the website? Any guesses? All right, I'm going to assume somebody said the two big ones, because that works well for the talk. So, thank you. So one of them, yes, is TypeScript, and the other is Rock, all the way at the end. So this makes you think, do you need a lot of dependencies to run a compiler on your website? Turns out, no, you just kind of need the compiler. That's like one dependency. That doesn't necessarily require a whole bunch of indirect dependencies. You're going to have to look closely, and people in the back might want to scoot all the way up to the front. I'm going to add to the stacked bar chart. Here's the TypeScript dependencies. I'm going to go back and forth so you can see this. It's kind of blinking. That's how much of TypeScript website's dependency graph is the compiler. So it's not that. So what is all that stuff? Well, I looked into this. I didn't spend a ton of time looking into it. But basically, all of this comes from basically one dependency or cluster of dependencies, which is Gatsby. I never used this. I don't know what it is. A website I saw on the internet somewhere it said the best React framework. I don't know. I've also heard people say it's obsolete or something like that. It used to be cool. Whatever it is, it's bringing in a ton of indirect dependencies. So you could use Gatsby for this and have, I guess, about 1,500 indirect dependencies from it. Or you could not have any dependencies because it's a static website, just like in 1996, and you don't have to do that. They're all doing the same thing. So again, how much of this is technical, how much is cultural? I think it's really hard to make the case that every single one of these 8 websites that are all doing fundamentally the same thing, documentation, syntax highlighting, examples, yeah, they're like, no, this TypeScript website needs to have this many dependencies. There's no other way. It has to be cultural. And I can make an even stronger case for that after I fill in the rest of these by just looking at how they're grouped. So which of these are using package managers created by the same people? So for example, TypeScript and Node.js, both using the NPM package ecosystem. Same package manager, I would argue, same culture, kind of makes sense. Ruby and Rust have about the same shape. They have about the same number of direct and indirect dependencies, like small number of direct, large number of indirect, but nowhere near the NPM level. Now you might say Rust and Ruby are totally different programming languages. They are, but fun fact, when Rust needed a package manager, they were like, who does a good job of making package managers? Oh, Ruby gems. So they went to the bundler folks and the Rails core team people and were like, hey, can you help us make a package manager for Rust? And they did. And I would argue, when I saw this, I was not surprised. I was like, oh yeah, culturally, it's the same people. So wouldn't you expect that when they're making their website, that culture would carry over into like about how many direct and indirect dependencies you're going to have? This is not like perfect science here, but I look at this and I'm like, oh yeah, I get it. Python and Go don't really have anything in common. Python looks like it has about a 1-to-1 ratio of direct to indirect dependencies, which you don't see anywhere else on the graph. But also Python doesn't really have any cultural relationship when it comes to dependencies to any of these others. Same thing with Go. They have their own kind of philosophy that's really distinct from all these others, which we're going to talk about later. And then Zig and Rock, but back here in the like almost no direct dependencies and like maybe a little tiny sliver of indirect, Zig uses Zig's package manager and Rock's compiler is written in Zig, so it also uses Zig's package manager. So again, not really surprised that there would be some cultural overlap there. So I'm going to claim, yeah, like I think this is mostly cultural. Because again, these are all static websites about programming languages. You clearly don't need to have this many or this few dependencies to do that job. It's just that I think people are choosing what is sort of normally done in their respective ecosystems. These are cultural norms, not technical necessity, I claim. And we can see this in game dev as well. In some cases, in even more extreme examples. So I picked some 9 games here. We're going to do like an abbreviated version of that same exercise. I picked these not because they're the most popular games, but because they are both popular, or some degree of popular within their respective ecosystems, and also either open source or source available, so I can actually look at like what are their dependencies. Because a lot of games are proprietary, obviously. So here we have a kind of similar looking graph. We have like 2 very big ones, and then like 2 significantly smaller ones, and then a drop off down to basically 0. So same kind of deal as what you'd see with websites. Now, of course, these are a little bit apples and oranges, because with the websites, they were all websites about programming languages. They're all static, mostly documentation, stuff like that. These are all very different games with 2 exceptions. 2 of these games are remakes of the same game. Now, again, I'm going to ask you the same question. Can you guess which 2 games, without knowing which ones they are, just based on the bars, which 2 are remakes of the same games? And I'll give you a clue. This is also a trick.
The 2 left ones.
Yes! Great answer. Okay, so this is one of them. And the other one is like this one down here. Now, this actually does make a little bit more sense than the other case, because if you look at the blue part of the graph, they actually have about the same number of direct dependencies, so like 29 and 30 respectively. But then one of them has a wildly different number of indirect dependencies compared to the other. And again, these are both remakes of the same game. They have a couple of differences, but they're really just like fundamentally like, oh, we like that game and we made like a modern version of it. So the ecosystems in question, these are Rust, C#, and C++. Now, this is not telling like a super clean, like, oh, look at this perfect narrative of like, oh, look, Rust has lots of indirect dependencies. Actually, they kind of all do. So like here you see like, really high total numbers of dependencies here, because of all these indirect dependencies. But like this game has a lot of indirect dependencies and very few direct, and so does the C# game right next to it. They're almost neck and neck. And in fact, within the C# ecosystem, you see a lot of diversity of like ratios of direct to indirect dependencies, number of total dependencies, et cetera. C++ is kind of off doing its own thing, though. Like in C++ land, I don't see any green at all. There's like no indirect dependencies at all, which is wildly different than C# and Rust. And the number of direct dependencies is also extremely, extremely low. So what's going on there? Well, I would argue that if you're going to pick application development and you're not talking about something like a database, like Richard's talk yesterday about SQLite, I'm guessing he doesn't have 1,800 indirect dependencies in SQLite. I haven't looked, but I'm pretty sure it's a lot lower than that, probably zero direct dependencies too. Zig has one direct dependency and it's LLVM and they're trying to get rid of it, but it's a hard one to get rid of. So among like application developers, I would say that C++ game dev culture is about the opposite extreme of what you see from like NPM culture, where you just see tons and tons of dependencies. So in NPM culture, it's common to have many direct and also many indirect dependencies, and usually the ratio is wildly in favor of indirect. C++ is like very few direct, like we saw in that graph, and basically no indirect normally. You could argue that this is because it's so much easier to add dependencies in NPM. NPM makes it easier to add dependencies, and maybe the C++ game developers would like to have more dependencies, but it's just less ergonomic because they don't have the equivalent of like a package.json. I've heard that the C++ world is getting some package managers along the lines of NPM, but they're not really mainstream yet. So in C++ game dev culture, it's like if you want a dependency, you're going to vendor it, maybe fork it, like you're going to add it to source control. Now you might say like, yeah, that nobody wants to do that. Like your indirect dependencies are going to have to like, how are they even going to talk to each other? Like how are you going to share code between them? This is going to be really painful. But I actually talked to a famous C++ game developer, Jonathan Blow, who's made games like Braid and The Witness and now Order of the Sinking Star. And okay, he was a C++ game dev for the first two games, but now he made his own programming language that's a C++ competitor. But when we were talking, the reason he's making the scare quotes is he's using scare quotes around the word vendored, which he thinks is kind of a funny word because he's like, what do you mean? That's just like how you do things. Like, why is there a separate word for that and why is the word vendored? It's just that's how you get dependencies. And he made a pretty strong claim in this talk. This is in the Software Unscripted podcast. If you're going to depend on external things, it should be in a folder that you check in. So this is not like, oh, this is inconvenient, I wish it weren't this way. He's like, no, this is the right way to do it. And he went on to give some examples of things like, he's like, if I'm on a desert island, I don't want to need an internet connection to build my code. I want to be able to just have everything in my checkout. If I go back in time to an earlier checkout, all my versions of the dependencies are right there in the checkout. I don't need to go back to the internet to go get new ones. I just want everything in source control. Now granted, if you have 1,800 dependencies and like a gigabyte of downloaded NPM node modules, maybe you don't want all that in source control. I get it. But if you have a small number of them and basically no indirect dependencies, that stops sounding like such an unreasonable idea. It actually sounds like, oh yeah, I could see some upsides to that. NPM culture has a lot of micro dependencies where you have like a very, very small dependency that maybe doesn't need to be a separate package. We're going to look at one of these later. Anyone ever heard of leftpad? So this one was famous for being a counterexample to both the desert island and also the size of your dependencies philosophy. This is a library whose entire job was to give you one function, and that one function's job was to pad the left side of a string. So you could say, like, for example, I want like 10 characters in my string. If it only had 8, it would add 2 spaces in front of it or something like that. So you could align monospace font things, I guess. This was famous because the author of this package removed it from NPM back when you were allowed to do that, and it apparently broke a ton of people's builds, which tells you two things. One is, wow, there are some really tiny micro dependencies in the NPM world, and two, a lot of people are not caching their builds. Because like, why would it matter to your existing project that was yanked off of NPM unless you're going back to NPM on every single build? So this is like kind of the opposite of like, yeah, if you're on a desert island, you would have been totally hosed if you'd been depending on that. But his point was like, there's just a whole category of problems you don't have to deal with like that if you're just like, put it all in source control. So you do see like the opposite of that, like mega dependencies or mega deps. I don't really hear that, but I like kind of how it rhymes with megadeth, so that's cool. But we're talking about game engines here, really. Like you do tend to see like, I'll depend on Unreal Engine, which is like multiple millions of lines of code. That's one giant dependency, and then there might be some like plugins for that as well. But you definitely don't tend to see things along the lines of LeftPad. Like in game dev, it's going to be more like you're going to get like a physics library, or you're going to get like a networking code library or something like that. NPM culture, it's like pretty common to download on build. Apparently, a lot of people don't even bother to configure a cache for it. Whereas here, it's like, yeah, either you're going to have it in source control, or it might be a system library. We were talking at dinner last night about this, and Andrew Kelly brought up an annoyance that he has is sometimes you're on Linux, and they package LLVM for you and make it available in the operating system, which on the one hand could be kind of convenient and nice for code sharing. But on the other hand, they often enable some optional libxml dependency for some reason, and then end users of Zig are like, hey, I can't build Zig because I don't have libxml, and Andrew's like, I don't use XML. LLVM normally doesn't use XML. It's just because somebody on the system side has decided that they wanted to enable that optional dependency that you're being broken right now. So that has its own downsides, but it is something that happens in game dev culture, like DLLs just being expected to be ambiently on the system. Update frequency is a whole thing. So NPM culture is like update constantly, basically. You should always be maximally up to date. And then again, here we have like pretty much the opposite. It's like, from what I hear, game dev, it's like, yeah, you don't update your dependencies. Like, physics is not going to change that often, like, unless you have some reason to do it. And I did find somebody who has a really unusual culture, but I really appreciate it, who has a take on this that's basically something I haven't really heard, but I think more people should hear about, and so we're going to hear about it now. This is Mitchell, we haven't gotten him yet. Russ Cox, you should hear about this one too. A key feature of Go's package management system, which he developed, is that upgrades do not happen until a developer asks for them to happen. So this is like when they were designing Go's system. Go is definitely not like vendor everything, fork everything. Go is like, they have a package manager system, but the philosophy is like somewhere in between these two extremes. It's like, you should always get sort of like the minimum version that satisfies your dependencies. You should upgrade carefully and intentionally, not as a matter of course and automatically. It's sort of like maybe a middle of the road approach between these two. And you can also find like, similar points on the spectrum of like Java is maybe somewhere between Go and NPM, and Ruby I would also put in that category, things like that. The extreme one that I wanted to show you is Mitchell Hashimoto. Anyone know Mitchell's work? Ghosty, or yeah, cool. Yeah, HashiCorp. Fork your dependencies. Trim them to only your use case. In other words, like your dependencies, you're going to get probably a Swiss Army knife off the shelf, and it's going to have a bunch of stuff that you're not actually going to use. He's like, yeah, just delete those parts. Did anyone ever do this? Wow, okay, cool. Yeah. This is an awesome conference. Like, this is not a mainstream thing to do. But it makes a lot of sense. Like you have this code that you've downloaded. There's a bunch of code in there that like is not just unnecessary to you, but it is probably actually harmful to your users in the sense that like there's going to be a bunch of conditionals to support all that flexibility that you're not using. It's going to slow your stuff down. If you're delivering it over the web, it's going to be increasing the size of your binaries or your compiled JavaScript or whatever the case may be. Never update unless it breaks for your users. In other words, if there's a problem and you need to fix the problem, then sure, update if the update will be the solution to the problem. But don't just do it as a matter of course. I've been vocal about this for 10 plus years. I've always said that updating is way riskier than latent bugs. Now we're going to talk about why he's saying that's risky and also the latent bugs he's talking about in a second. The latent bugs can be tracked and CVEs monitored. If you're updating a dependency, it's on you to analyze every single commit in the full transitive set of dependencies, so direct and indirect dependencies. Does anyone do that? Go commit by commit on every single, yeah. One, okay, and it's Andrew Kelly. Yeah, most people don't do this. Most people do the opposite of this, where they just like press the update button and are just like, yeah, now I'm up on the latest version of Windows. I mean, NPM, whatever, dependencies. I think maybe part of this comes from like operating system auto-update culture, where it's just like, oh yeah, there's like a new version of the thing. Yes, please. The thing is, your operating system has a completely different level of vetting than your 1800 NPM dependencies. Like, there's just like people whose job it is to look for security probability, problems and stuff like that. That's just not happening in, like, these are not the same things when you're pressing that button. If you don't see anything compelling, don't update. I remember at HashiCorp, once in a while, an engineer would try the updated dep or replace a do-it-yourself library with an external one, and I'd always ask, show me the commit we need. Don't update for the sake of it. Now this is, again, not normal, but if you're thinking like, actually this does sound kind of nice. I can see an argument for why you would want to do this. Yes, it's going to take more time, but there are a lot of benefits to doing this, and we'll talk about those in a sec. if you ever find yourself getting pushback on this, I might point out, if somebody's saying like, I work in a business, like we have to go fast, we have to like ship things, we cannot take the time to vet every single one of our dependencies in this way, we can't go commit by commit, we can't trim them down, et cetera. How are we going to be a successful business if we do that? Well, HashiCorp, started by Hashimoto, it's named after him, he co-founded it and then went on to, using this exact dependency culture, go public and became a billionaire. So you could point out like, well, if we do this, we will all become billionaires. Now, I'm not saying that logic is guaranteed to hold, but the point is, like, clearly you can have a very, very, very wildly successful business while doing this. It's not inconceivable. It's not common, but it's not going to prevent you from being a successful business. Far from it. Feeling pretty swell about this mentality with all the supply chain attacks happening. So let's talk about that. Let's play a game. It's called Dependency or No. So here's a GitHub issue. This is from 2014, where someone says, I need a new function added to this dependency I have. I use this library. I would really like for it to have a flat map. This is like a streaming library. It does stream stuff. I need this right now, unsure how to continue, but fortunately the person was able to unblock themselves by writing the function themselves. This is 4 lines or 5 if you're going to count the closing braces. That's 20% of it is the closing braces there. GitHub has provided a very convenient way for you to obtain this dependency. They put a button right there. You can copy the code and paste it into your code. Now, there might be licensing concerns, granted, because this person did not say I'm making these 4 lines of code available, sorry, 5, on a particular license. So you might look at this and understand the details of what they've done and maybe think I could re-implement this myself. It might be hard, but I bet you could do it if you were concerned about the licensing. But what actually happened was, so my verdict here is like not worth a dependency. Don't add a direct or indirect dependency for this. If you want this functionality, just copy paste it in, or if you're like Mitchell Hashimoto, you would probably just say, I don't want that function, I don't care, I'll just ignore it because I'm not using it. This person needs it, so they've added it to their code, that's fine. I'm not gonna add it to mine. Everybody's great, everybody's fine. So what actually happened is that the author said, hey, if you publish a flat map module, which ended up being a package, a separate dependency, so they added a line to their package.json to like add this instead of the 4 lines that would have taken to have the entire dependency. I'll go ahead and merge it. So they did go ahead and merge it. Fast forward a little bit. This is an issue that was open on the repo called backdoor dependency, question mark. So what happened was they added an indirect dependency on this new flat map stream thing, and it turned out that person was malicious. And what they did was they published a little patch release, which made it so that instead of doing this little 4-line thing, it also ran some code that tries to steal all your cryptocurrency. So that was not ideal. That was not an ideal thing to upgrade to if you wanted to get that indirect dependency. But some people did, and then there was a follow-up thing like, I don't know what to say, a whole postmortem on the whole thing, and now the repository's been archived because nobody wants to depend on it anymore. This was, shall we say, avoidable. Well, let's tell you about Dependabot. Has anyone ever used Dependabot? Okay, a lot of people. Dependabot's website says, keeping your dependencies updated is one of the easiest ways to keep the software you build secure. I want to go back to the previous slide for a second and talk about... So, now, to be fair, updates are a double-edged sword. On the one hand, they can get you malware. On the other hand, they can also fix latent bugs. That's what Mitchell was talking about with latent bugs, and we're going to talk about an example of that as well. There is an important question, though, like which is more likely in this day and age. While it's critically important to keep your dependencies updated, in a recent survey, 52% of developers said they find it painful. So that's the problem, is that pressing the button to update your dependencies and not vet them at all, that's the thing that needs to be solved. Don't worry, Dependabot alleviates that by updating your dependencies automatically so you can spend less time updating dependencies and more time building and obtaining malware. I'm not a big fan of this approach. I think Mitchell's approach is better. We're at Software Should Work. One of the ways your software can stop working is if you update your dependencies uncritically and end up obtaining not necessarily just malware, but also just like bugs. I mean, in the ideal world, every time you press the update button, you get better performance and fewer bugs, like bug fixes and stuff like that, maybe more functionality, or maybe the dependencies just get smaller. And they do the trimming out work for you of stuff that turned out to be unnecessary. But in practice, all of those can happen in reverse. You can get more bugs, you can get malware in the worst case, you can get more bloated stuff that's adding more functionality that you're not using but which you're still paying for at runtime. Updates are a double-edged sword, and we shouldn't pretend that updating is just an unalloyed good. And I don't think culturally this is the way to go. I think Mitchell is a lot closer to what's better, even if I don't personally go as far as he does. So I combined the two graphs from earlier. This is like all the websites and all the games and like sorted by dependencies. So here we have the like TypeScript website with the 1,800 dependencies all the way down to the Rock website. Some of the games down there have very few dependencies, direct or indirect. And again, I wanted to just sort of highlight the point that you don't need a ton of dependencies to do these things. Like these are very successful games. I would say probably the most successful popular game of all of these is this one right here, which was Doom 3. They just made the engine themselves. They did everything from scratch pretty much, basically no dependencies, and they did a good job with it, and it worked out. We saw like these websites are all doing the same thing. 2 of these games are doing the same thing, and now we can kind of see why I'm showing you these graphs. It's not like I'm trying to be a jerk and say like, oh, look at these silly people with their ridiculous numbers of dependencies. It's like no, any one of these 1,500 dependencies here could have been event stream, which was the one that added flat map stream, and that got you malware if you did that. This is a real concrete downside. This is not a joke. This is not just like, it's bloated, but we're not using it, haha, no big deal. Like this is a real vulnerability surface here. Now the other example that I mentioned earlier of like a dependency that's not malicious but can cause you problems anyway is log4j. Anyone hear about the shell4j? Yeah, or log4shell? Yeah, so basically this is like a super common dependency in the Java ecosystem, and commonly direct dependency, commonly also indirect dependency. And what ended up happening was basically they released a new feature, and the new feature turned out to have a vulnerability that nobody caught. Unintentional, it was not malicious, it was just like they didn't realize the implication of what this feature meant if somebody decided that they wanted to abuse it. It had already made it out into the wild, the new release, a lot of people had updated to it before people realized this, and then were sort of scrambling to patch it. And that would be an example where once they had patched it, you would want to update as fast as possible to get the fix so that you're not vulnerable anymore. Unfortunately, if you have a ton of indirect dependencies, what ended up happening with this in practice was that I am using log4j, whatever, I update the latest version, but I depend on something that hasn't updated, or it depends on something that hasn't updated. And so the number of indirect dependencies made this a much worse vulnerability because the hard part was getting the patch out to every single one of your indirect dependencies. And that was what sort of caused the problem. So again, if you're updating super fast, you're vulnerable to this category of thing where it's something malicious that they're just trying to sneak out the door and see how many people will update to it before they get discovered. Here, this is the more passive latent bug that Mitchell was talking about, but his point was, look, there are CVEs for this. Like, when these things come out, you get notified. It's not like you're going to be totally in the dark. If you're subscribed to these, something big like this, you're going to hear about it, and you can then know I need to upgrade as quickly as possible to remove the vulnerability. But at that point, it does matter how many indirect dependencies you have that are using the thing that turned out to be vulnerable. So lower number of indirect dependencies means you're less vulnerable to all of this stuff. I asked the question earlier, like, Dependabot claimed this is like the way to keep yourself safe is to do upgrades all the time. And so there is this question of like, is the log4j latent bug more common, or is it the more, malicious attackers? It's not even close. Like maybe it was at some point in the past, but these days, like 2024, they found 500,000 malicious packages just in 2024. This is like a 1.5x increase over 2023, and it was like 1,000+% increase compared to 2020. Like the graph of how much the frequency of this stuff is happening is just going up and up. And you can see why. Because culturally, it's a totally normal thing to just have 1 million dependencies and not vet them. So if I'm an attacker, I'd be like, great, this is awesome. This is like, what a time to be alive. Another way to look at this is that what I've really graphed here is like, this is your exposure to compromised dependencies. Like the more total dependencies you have, especially if you're not vetting them when you're updating them, the more vulnerable you are to this stuff. And unfortunately, this is a downside that we are all living with now. I mean, a lot of the software that we use is this way, and a lot of the way that you accumulate indirect dependencies because you find something on the shelf that legitimately does satisfy your use case, and you're like, yeah, this is actually going to save me a ton of time, or maybe it's really hard to implement correctly, so I do want to pull this thing off the shelf, but it's going to pull like 20 other things with it. And I don't like that, but I don't really see many alternatives. So one of the takeaways from this talk is if you're building a library like this, think carefully about the indirect dependencies that you're imposing on people who are going to use your thing if they decide that your thing is the best fit for their situation. The pithy, more eloquent way of explaining all this graph, of summarizing it all, I'm going to turn to the immortal words of Biggie Smalls: mo dependencies, mo problems. All right, so let's go through a real quick concrete example of this. So this is actually something that I ran into when I was working on the Rock programming language website. So like I mentioned earlier, we have this like section of the website on the home page, if you scroll down a little bit, where you can just type in some Rock code and press run and just see what the output is. So you can kind of get a feel for the language. Now part of this is like we have a WebAssembly binary for the compiler, so the compiler is written in Zig. So unlike the TypeScript website, that part's not in JavaScript because we don't have a JavaScript version. That's like one dependency on the compiler itself. But there's another thing that we need, which is just for the website that's unrelated to the compiler, which is we want syntax highlighting. Like when you're typing in here, if you're editing like the string literal, we want it to be highlighted like a string literal and whatnot. That's not something we can just do ahead of time because we don't know what you're going to type in there yet. So that needs to be in JavaScript. So I was looking at this and I was thinking back to like back when I was in the web development game, if I need syntax highlighting on my programming language website, what's the first thing I do? I'm like, oh, well, this is a problem that has been solved many times over. I'm going to go to NPM and just type in syntax highlighting or syntax highlighter and see what's there. And I immediately did this, even though I already went a different direction. But I was like, well, let's just see what comes up. And one of the first things that happens when you start thinking about with the mentality of like, oh, I'm going to go get a dependency off the shelf. Let's go see what I can find. One of the first things that happens is that you start thinking about which one is the right one for me. So in this case, as it turns out, like the first three here, this is like syntax highlighting for terminals. This is like for a UI editor, like the Toast UI, whatever that is, highlighting in curl commands. Like, yeah, because NPM has a mix of Node stuff and web stuff. So like this is all just like Node.js dependencies. They're not helpful to me, building my website. But it's really easy when I'm doing this to like shift my mindset away from like, what's the problem I'm trying to solve, to being like, which thing do I pick off the shelf? Like that's where my headspace is. I'm just thinking about the shelf. I'm not really thinking about the problem anymore. Eventually I settled on like, oh, well, there's highlight.js, which I remember from back in the day. Their website says the internet's favorite JavaScript syntax highlighter, 192 language, 512 themes, automatic language detection, any HTML markup, 0 dependencies, any JS framework, Node.js and Dino, tons of releases. Is that a coincidence? Like, come on. Version 11.11.1, I think they're cheating. That's a very suspicious, anyway. But I look at this and I'm like, okay, cool. I figured out which thing on the shelf I'm going to get. It's good old highlight.js, and it's going to solve my problem of syntax highlighting. But if I take a step back, I think like what do I actually need? I don't need 192 languages. I need one. I don't need 512 themes. I need one. I don't need automatic language detection to detect the one language that I know I need the highlighting for. I really don't need, like all I need here is I just need a syntax highlighter. And actually, it's even worse than that because I need a syntax highlighter for this new programming language that's not in their 192 languages. I need a syntax highlighter for rock syntax. So if my mindset is like getting the thing off the shelf, where I would go next is I would think like, oh, well, that's okay because highlight.js supports custom languages. Obviously, they have a way that you can add languages. But the way that they do that is with regular expressions. You give them regular expressions, and they run the regular expressions and decide where the highlights go. Well, the problem with that is that regular expressions, there's a reason that, well, there's multiple reasons why programming languages don't use that as the way for their actual compiler to do things. A really easy example of this is string interpolation. So Rock has string interpolation. Inside that curly braces in there, the string interpolation, you can just put whatever Rock expression you want. Technically, although nobody does this, nobody should do this, you could put another string literal inside that expression with its own interpolation, another one inside of that. You could nest them. I wouldn't recommend it, but it is something that that the language allows. But that's not possible to represent a regular expression. It's not regular. So you can't, literally cannot do the whole correct thing in the language. That's an extreme example, but there are other edge cases where you've just seen regular expression-based syntax highlighting break and just not work out, and you see something like, oh, that's not quite right. So this kind of bothers me. I'm using this dependency. It's asking me to write things in regular expressions, which is not how I have it in the compiler, so I can't just directly translate from what I've already got that works into JavaScript, on top of which that's going to be a really painful amount of work for me to do because I have to look at okay, wait, how would I translate this to a regular expression? And then what I get out the other side is less correct and has worse bugs than what I started out with. So what I actually ended up doing was I just said, okay, let's just not get something off the shelf at all here. What I'm going to do is step one, I'm going to port my tokenizer, which already is in Zig, to JavaScript, and I'm done. Because that's all I needed. I just needed the logic and the there's okay, there's the theming and the colors, but I had to do that with highlight.js anyway. I need to pick the colors and whatnot. So really what I ended up doing was I spent less than an hour just asking a large language model to be can you translate from this language to this language, and then iterate a little bit because it didn't do the greatest job. But the point is I ended up with something that's actually much nicer for me in many ways, and also much nicer for my users. So this ended up being 6 kilobytes, whereas highlight.js is 9 kilobytes, compressed, without any languages at all, and it's 12-ish if you add JavaScript in there. So this is about 1,000 lines of code for me to maintain, but it handles all the edge cases. There's no problem with string interpolation or anything else. It's going to run faster because it's not using regular expressions. It's doing the real thing. And it's easier to make syntax updates because if we do change something about the language's tokenizer, this is one-to-one. It's just a direct port. It's very easy to say oh, we changed this, great, do the corresponding change over here, as opposed to having one of them be in regular expressions and one of them being in a completely different style. So This ended up being like kind of the obvious way to do things. Now I bring up this example because this is, if you multiply this by all the decisions that I made with this website, this is how we ended up with basically 0 dependencies. It's just me looking at like, okay, what's the actual problem we need to solve here? And being aware of what's on the shelf, because I'm not saying you should never have dependencies. Like clearly there are plenty of cases where you're like, absolutely the correct technical decision here is to pull something off the shelf. Really what the point that I want to make is that there's a whole spectrum of ways you can do that. You can do that eagerly and say like, this is my mentality, is I must find something off the shelf, I'll pull it off. I don't know what a screwdriver is, I will never open it up and make changes to it because I've never heard of that. You can have a whole spectrum of experiences here. You can either say I'm going to do it myself. Maybe you start off thinking you're going to get it off the shelf like I did here, and then you end up concluding you should do it yourself. Or maybe you get something off the shelf and you hack it up, Michio Hashimoto style. You say like, I don't need any of this stuff, I'm just going to chop this parts out. Maybe you find some code that you like and you just copy paste it in and just add attribution. If it's licensed, you can just put a comment that says like, I'm licensing this under MIT, whatever. In our compiler, we've taken stuff from the Zig's compiler, thanks, and we just put a little comment that says, hey, this is from Zig, licensed under MIT, which is Zig's license, thank you very much. Sometimes it's a small thing, sometimes it's a whole file, sometimes it's multiple files. You don't have to just have this all or nothing, like let me just pull every dependency I can get in mentality. There's a whole richness of options here, and they have a lot of different trade-offs. So if we go all the way back to like the beginning where we were talking about like, these are all web applications or websites, they're all doing the same kind of job. There's a whole spectrum of different dependencies you can do to do this job. Again, I'm not saying that there's no advantages to these things. Some of this stuff I look on the slide and I know what they do, and they would have been pretty nice for us back in the day. Like having like bare metal servers when you actually like need to upgrade them for traffic reasons, kind of a pain. You need to go like physically assemble more servers and take them out of the co-location facility. And if you need to upgrade to a bigger space in there, you got to pull all the racks out and put them in a bigger space, right? Having something like AWS Lambda that's like an abstraction over all that, where you're just able to focus on like my request and response logic, there's a lot of value to that. The problem is that if you take that mentality too far, you can end up with the number of dependencies and their interrelations becoming a problem in its own right. And the number of direct and indirect dependencies that you have becomes a burden unto itself, completely separate from the individual value that you're getting on a case-by-case basis. So is this all technical stuff? Are people doing web startups in 2026 saying, I have determined that the absolute ideal stack is every single one of these things, and if you tell me to take one of these away, I'm going to fight you on it because I'm going to say, no, this is absolutely the best way to do it? I kind of doubt it. I bet that a lot of this is cultural and not, if you sat down and tried to look at what are the actual problems we're trying to solve, that you would end up with something smaller than this. Okay, summarize. Dependency count, I claim, is mostly a cultural choice, not a technical choice. We saw lots of examples of both games and websites, and you can do that exercise for all sorts of different domains and just find that like, here are very similar things. It might be a remake of the same game. It might be 8 different websites that are all about just showcasing a programming language, and they just have wildly different dependency counts from like 0 pixels to 1,800 dependencies to do the same job. You don't have to choose that many dependencies. More dependencies means more attack vectors. Like maybe back in the day that wasn't such a concern, but it is a real concern now. People are trying to come and compromise your machines. This is a real thing. More frequent upgrades also means more attack vectors. Again, maybe back in the day it was best practice to just press the update button as frequently as you can. Not anymore. I think the risk has shifted there, and it's actually just more dangerous to be constantly updating and not thinking about it, as opposed to the Michio Hashimoto school of vet every commit, don't upgrade unless you have a very specific thing that you're trying to get out of that. Nothing is wrong with copy paste plus attribution. This is a way that you can very quickly get the subset that Mitchell was talking about. If you just need like a 4-line function, you don't need to add an indirect dependency to your package. You can just copy paste that into your code. You don't even need to tell the maintainer about it. You don't need to upstream it. If you want to, okay, sure, but if you are, probably just add it to their list of functions as opposed to introducing a new dependency, because that's just a new attack vector. And finally, if there's one message I could have from thinking about all this, it's really just consider what's on the shelf versus forking versus doing it yourself. You don't have to just take everything off the shelf. You can think really carefully about what it is, and I claim that if you do that, you will end up with a slimmer set of dependencies that's easier for you to maintain, more customizable to your needs, and faster for your end users. In short, what you depend on is up to you. So it's your choice, whether you want to have a ton of dependencies or maybe not so many. Thanks very much. Yeah.
We have time for just a couple questions here.
Just a Quick question, when are you going to release the syntax highlighter on NPM so that it's available for...
When are we going to release the syntax highlighter on NPM? I actually have a personal no NPM policy, so I'd be going against that if I publish something on there.
I've heard good things. Thanks.
So I'm working at a Node.js shop with gigabytes of dependencies. I think there's enough people at the company that think that's a bad idea as well, but we're all a little black-pilled about thinking that there's any ability to change that. Do you have any practical recommendations? What could we do to try to affect that culture?
Yeah. So question is if you're at a shop that has a ton of dependencies, gigabytes and so forth, how could you make changes? Practical advice, one step at a time. So I would say you're not going to overnight change the culture. Cultures just don't change that fast. But what you can do is you can maybe point to this talk or maybe make some points about hey, we're talking about taking on this dependency. Do we need to take this on? Or maybe you go through your existing dependencies and say, hey, I was looking at this one and I feel like this could just be 3 lines of code instead of that dependency. Does anyone mind if I delete that? And just do little incremental changes like that. And then over time, hopefully, people will say hey, this is going well. Maybe we could do more of this, and then use that as a springboard to try to effect more of a change. If you're already sort of stuck in the swamp, it's going to take a while to get out of it. But at the end of the day, I think finding some way to make incremental wins is the way that you start that process.
Thanks. Great talk.
Thanks.
I think part of the problem is cultural by package maintainers and maintainers of operating systems and stuff like that. People of a certain age will remember the good old days when there were some releases that had new features, and then there were some releases that only had security fixes or bug fixes. And so you didn't mix the two. And I think a lot of the problems that we have now is that people ship both things. And often, if you look at the operating system release notes for Mac OS or whatever, it'll say, here's the things that changed. It'll say, a bunch of security and bug fixes. It doesn't iterate over each one of them. And you see this sort of thing kind of creeping into packages and modules and stuff for various languages as well. And I think that's really a core part of the problem.
Fair point.
Yeah, I was kind of curious to know if you have any theories about how we got here, because I was thinking that maybe the internet itself may have been a gateway drug to being in dependency hell.
Yeah, so I had another 45 minutes worth of slides on how we got here, but it didn't fit, so I cut it. But if anyone wants to see that talk, maybe I'll give it some other time.
All right, sweet.
Thanks for the talk, Richard. Great job. I'm curious what you think about OS package managers and kind of the Unix philosophy of tools that you just kind of grab off the shelf that do one thing, and it's sort of encouraged that you just pull a bunch of them together and do what you need to do.
Yeah, I mean, candidly, I don't have as much experience with OS package stuff. The software I build tends to be using more of the NPM type ecosystem, if at all. I generally, my personal philosophy when I'm building software is I try to avoid built-in system dependencies unless I know they're there on the OS for sure, like libsystem on Mac OS or something like that. But at the end of the day, as far as if I were involved in the OS packaging ecosystem, I don't know what the trade-offs are there, to be honest. I mean, maybe they're the same as what we're talking about here, but I know they have a pretty different level of vetting. I've heard Debian is particularly extreme with how they vet packages for security. They have a whole bunch of rules about things. So I'm just not sure how much of this applies in that world. Hopefully it's better, but I just don't know.
Yeah, that makes sense. Quick follow-up on that, since you mentioned the vetting. So there are a bunch of these companies now that just scan NPM to find any security vulnerabilities. What are your thoughts on band-aiding the problem by delaying any updates until a dependency is 7 days old and has been scanned by these companies that are spending millions of dollars to try to figure out if they're...
So this is the cool down idea of it's don't update your dependencies right away. I mean, that's less bad, right? So I mean, if I could sort my preferences, I would say my top preference would ideally in a perfect world be kind of do what Mitchell advocates, is just go vet them all myself. If there's a source of data, somebody else has vetted them, that I can look at very quickly and say oh, we found something, great, so much the better. I mean, I would rather know that than not know that. As far as leaning on that to be oh, now it's fine to update your dependencies constantly, again, one of the categories of problems is security vulnerabilities, but another is just performance regressions. Another is just the update is introducing new bugs. There's always going to be some amount of risk to updating as a matter of course, and that's where I think Mitchell's philosophy really shines. You know concretely what you're getting in exchange for that risk. So, would I prefer a cooldown? Yeah, like my order of preferences would be first Mitchell, second would be some sort of like, don't update immediately, but like, wait to see if researchers find problems or, people who are updating more frequently, maybe they find them the hard way. And then lower preference than that would be update always immediately as a matter of course.
Thanks.
Sure.
All right, give it up for Richard.